if you haven't tried this one already, make sure you pause the video and try it on your own first, and then just reference back here to make sure you have the right answer. So going through another DK problem, it says if you buy a 1993 Nissan minivan, which this picture here is a beautiful picture of my first car, this beauty here. My parents bought this minivan when I was born, and then when I turned 16, they let me have that as my first vehicle. The only difference was my minivan was tan, not this cool blue here. But anyways, you buy this minivan for $4,000 and it depreciates. When you see the word depreciates, that should tell you that it's decay at a rate of 13% each year. What is the value of the car after 3 years? So again, we just answer all these little questions. First one is, what is the initial amount? Well, the initial amount is $4,000. It's the value of the car, or the minivan. What is the rate of decay? Again, rate is my percent as a decimal, so I'd say 0.13, moving the decimal place over 2. What is the decay factor? Whenever we see factor, we're going to think, well, is it 1 plus my rate or 1 minus my rate? Well, since this is decay, and technically this is my B value, I have to do 1 minus my rate because I know that my B value has to be less than 1 for it to be decay. So it looks like when I subtract, I get 0.87 as my decay factor. This one says, what is the label? Well, I'm talking about the value of the car, so it would be money. Are decimals okay? Yes. Specifically, since it is money, we should have 2 decimal places. Decimal places. I said decimal places. What is the value of the car after 3 years? Well, if we think about our exponential model, y equals a times b to the x. A, my initial value is 4,000. Times b, which is my factor, which in this case is 0.87, to the x power. In this case, x is my time. In this case, my time is 3 years. So once I've written that out, I just go ahead and plug it into my calculator, and you should get the value of the minivan to be $2,634.01. That's our estimation of what the minivan's value is going to be in 3 years. Alright, hopefully that one went okay. Again, I would maybe pause it and try this next one on your own. You really don't know if you know how to do it unless you try it by yourself first. So why don't you pause it right now, try this one, and then come back and check your answer. So, in this problem, it says a town currently has a population of 4 million people. It says, but each year 25% of the population moves away. How many people will be living in the town 15 years from now? So it says, first off, what is the initial amount? Well, we start with 4 million people. What is the rate of decay? Again, the rate is my percent as a decimal, so 25% as a decimal. I move it over 2 places. It would be 0.25. What is the decay factor? So again, since they're moving away, we're losing people, we know that it's decay. I have to take 1 minus my rate, which is going to give me 0.75. What would be my label? Well, we're talking about people, so my label should be people. Are decimals okay? Absolutely not, right? We can't have parts of a percent. So no decimals, so we have to round. Here it says, what is the population in 15 years? Well, if I write my exponential model, y equals a times b to the x, a is at 4 million, times b, which is 0.75, to the x, in this case, x would be 15 years from now. So I have to put 15 in there. Again, I plugged that into my calculator. I got to round to the nearest whole number, so no decimals. The population in 15 years is going to be 53,400 453, and it has to be people. $53,453 people. Alright, so hopefully that one also felt okay. I do have one more on there, and I know it says optional, but it's not optional. We're going to actually do it, because I think it's good just to get a bunch of practice with these before you get rolling with the homework. So it says, you buy a camper for $23,000. Camper depreciates, that's a big word, right? It tells us that it's going down, so it's going to be decay, at a rate of 11% each year. So first question, does it represent growth or decay? Well, we just said that. It's going to be decay because of this word right here, depreciates. This one says, what is the percent? Well, that's again kind of a freebie from the problem. The percent is 11%. Next question now, however, asks for the rate. Now, rate, remember again, is my percent as a decimal. So if I move this decimal place over 2, it's going to be 0.11. What is the factor? So again, when we're talking about percents, if it's growth, we take 1 plus my rate. If it's decay, I take 1 minus my rate. Since this is decay, I have to take 1 minus 0.11, which is going to give me a 0.89. Next question says, what is this problem talking about? What would your label be? Well, we're talking about the value of a camper. So we're talking about money. Should you use decimals? Yes. Why? Because money has 2 decimal places. Not 1, not 3. It has to have 2 decimal places. And lastly, this one just says, what is the exponential model? Notice this problem's a little bit different because it doesn't say what is the value of the camper after 5 years, 10 years, or anything like that. We just want to write that equation, and that's it for this problem. So we're actually not going to find an actual answer here. So when I write my exponential model, I'd say y equals, A is my initial amount, which is this 23,000, times b, which is this factor of 0.89 to the x power. And this right here is our notes for the day. So once you have all the notes completely done, you can go ahead and show them to the sub, and they will give you your worksheet for today. So this worksheet is along with your growth worksheet will be both due tomorrow. We'll have some time to go over questions on them. We're going to do some review tomorrow, and then we're going to have a quiz the day after that. If you're working on this later and you have questions, feel free to shoot me an email. I should be able to answer those for you. Again, hopefully things went okay. Make sure you get that worksheet done and have a great rest of your day.